Welcome to Helpful Hints for 1033 Lab Project for Chapter 3. We're going to be exploring modeling real-life data with linear models. So we're going to be graphing lines and using properties of lines to solve problems with real data. First of all, you're given a table. This is an XY chart. So you have your X values right here. You have your Y values here. We're also going to start using the notation f of x instead of y. So a function evaluated at x. So there's a graph where they've plotted the approximations. Now, the approximations on this graph are going to be these dots right here. So those are your approximations. Now, there's a line that goes through them, and the line has been created using statistics and statistical methods that we haven't explored yet. That line has been provided. Now, what they want you to do is you are supposed to identify some coordinates, not actual data points, because if you were to try to look through specific data points, this line that goes through the first two data points would be significantly different than something that goes through these two data points or these two or these two. So we don't want to use any of those. You might be able to use two of those data points if you choose the ones that are the best fit, but we want to identify if we can find some coordinates that are from the line itself. So, for example, I might want to pick something that's an estimation of my y-intercept. Y-intercepts are usually good points to pick. Maybe that one, or that one, or that one. It's easy to identify these coordinates here because if I can identify one of these spots from this line, I can follow it down to find my x value, and I can follow it over to find my y value. So this one, I would find the number here, and that would be the x value that goes in this spot. I would follow it over here, and that would be the y value that goes in this spot, and then I have a coordinate. So estimate the coordinates of 2 points that are on the line. So you're going to do the last thing twice. You're going to estimate 2 different coordinates, and you need 2 of them in order to be able to find the equation of a line. List them here. What is the slope of the line containing the 2 points that you stated in number 3? So if we're talking about slope, then we know we're dealing with some sort of m is equal to, and the way your textbook typically writes it is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. There are a couple of different ways that we could write this, but that's the one that you're going to see a lot. So use those 2 coordinates from before, the 2 that you would have put in here. So you have your x1, y1, and you have your x2, y2. So those will give you the data points that you need for that slope. So once you've done that, you're going to get a single number. And so then you get some sort of m is equal to a number. And identify if this number, is it positive, is it negative, is it increasing, is it decreasing? Look back at your line and see if increasing or decreasing makes sense. Find the linear function that passes through the 2 points that you stated. Now this is going to be some sort of line in this y equals mx plus b format, except that you're not going to use y equals mx plus b. You're going to use f of x equals mx plus b, where you're going to replace this m right here with a number. You're going to use the number that you found for number 4, and you're going to replace b with a number. Now, in order to find that b, you have a couple of different options. If you chose a y-intercept as one of your 2 original coordinates, then you already know what b is, because b is the y value when x is equal to 0. So if you chose x to be 0 and then approximated a y value there, then you already have the b that you need. If you didn't do that, then you're going to find this right here, find by using this the point slope. And when you're done with that, you should have some sort of f of x equals a slope x plus an intercept. Using the function that you found in number 5, replace that value with f of 12. So let's identify that this 12 right here means that this is an x value. So you're going to have f of 12 is equal to, and the m is a number that you already found. You're going to use 12 for x and then plus b. So at this point, all 3 things should be numbers, and you should evaluate this. But when you found that number, when you found the result when x is equal to 12, then you're not done yet, because what you have to do is identify what year we're talking about. Go back to the first page and identify what year x is 0, and then you're going to add 12 to that, and then you have a sentence at the end. So you're going to state, in the year, and then the year that you find, there were approximately, and then whatever you evaluated, that many violent crimes. In number 6, we're given an x value and we found a y, but at this point then we have a y value and we need to find an x. Now this is not, it's not the same thing as f of 50,000. That is not going to work. This is not what we want to do at all. We want to replace 50,000 for the y, for the f of x value. Remember that we're talking about violent crimes right now, and violent crimes are listed as y values. So once we're done with that, then you still have information that you need to provide. So when it says that you need to find the x value, that's a year, but you need to talk about what year that would be. Again, you're going to go back to what year is it when x is 0, and then add the x value that you found to it. So your answer should be in the form of a year, not in the form of an x. And last but not least, you can use your calculator to find the line of best fit. And we call that linear regression in statistics, and they gave you the formula for that. Now what your job is to identify their slope, the one that came from statistics, and see how close your slope was. Was your slope reasonably close? Was your intercept reasonably close?